Hey guys, welcome back to another episode of Theory Thursdays. This time we're taking a geometry question that comes from an SAT/SSAT practice problem. It says, for a square of side length S and a rectangle of side length 16 and width W, how do you calculate the length of the width given that the areas of these two shapes are the same? And given that the side length of the square is equal to twice the width of the rectangle. If you want to attempt this question, pause the video right here and go ahead and give it your best shot. Okay, now for the solution. Given that the areas are the same, we can say the area of the square, which is S squared, compared to the area of the rectangle, which is 16W, should be equal. So we can say S squared is equal to 16W. Because we know that S is equal to 2W, we can substitute 2W in the place of S, giving 2W all squared is equal to 16W. We can solve this by finding this. We can solve this by simplifying. We can solve this by expanding the brackets to find 4W squared is equal to 16W. We can then carry over the 16W. We can then create a quadratic we can then create a quadratic equation by saying 4W squared minus 16W is equal to 0. If we factor this equation by taking out 4W, we're left with W squared minus 4 is equal to 0. If we factor this equation, we're left with 4W, open bracket, W minus 4 is equal to 0. From here, we can say that either 4W, from here, based on our understanding of how to work with quadratic equations, we can say that 4W is equal to 0. From here, based on our knowledge of quadratic equations, we can say that either 4W has to be 0 or W minus 4 has to be 0 in order that when we multiply them together, we get a 0. From our knowledge of quadratics, we know that for this to be true, either 4W has to be equal to 0 or W minus 4 has to be equal to 0, so that when you multiply them, the product is 0. That means we can say 4W is equal to 0, and W would therefore also be equal to 0, or W minus 4 is equal to 0, making W positive 4. In this case, a length cannot be 0 given this. In this case, we know that the width cannot be 0, so we're left to say that the width is equal to 4 units. W is equal to 4.